Hey guys, welcome to the 9.5 standard deviation notes video. I'm going to explain to you how to find something called standard deviation. Before I get too far in, deviate means to go away from. So standard deviation is calculated to find the average distance from data values to the mean. And one thing that I'm going to go ahead and say on this section is you're going to want a calculator. So if you don't have one yet, go ahead and pause the video and go get one, or you can plan on using the one on your phone as well, as long as that is what you were actually using your phone for. Standard deviation it's kind of a funky symbol. It's almost like an O with a little hat on top. It's called omega. And variance is the same symbol but squared. And I'll kind of come back and talk about the difference between those two in just a minute. So basically, the number that we're finding is how far most of the numbers we have are away from the mean. A smaller standard deviation, like say 2, means that the numbers are all within 2 of the mean. So if it's a smaller number, that means that you have closer data. And if you have a large standard deviation like 10, that means most of the data values are 10 away from the mean. That's pretty far. So that's really spread out. And then here's what we call the normal distribution curve. So this shape right here that gets kind of high right here in the middle, it's also symmetrical. It's called a bell curve. And what happens is this one right here, this is the mean. And if we add one standard deviation, then we get this part right here. And if we subtract it, we get this one right here. It's almost like a funky 6. That's kind of how I draw mine. I'll give you a second to make sure you've got yours labeled too. Okay, so there's a certain amount of data in between each chunk. Just like when we did box and whisker plots, each one was 25. But this time, it's a little bit different. From here to here is going to be 68.2%. So almost 70% of the data falls within one standard deviation if it is a normal distribution curve. We're not going to do a whole lot with this. I mainly just wanted to show you because this is why we actually do it. And then if you go all the way out here, oops, didn't mean to write through that. Oh well, keep going anyway. This is where we have 2 standard deviations, added or subtracted. This is 95% of the data. And then if you go out to 3 standard deviations, I'm not going to write this on the graph because it's kind of hard to see, but that actually means that you have 99.7% of the data. Now you might be like, why is it just 99.7? Because sometimes there's an outlier over here and over here, and that's why. So there might be like a number still left over there. So basically you have 70% of your data within the first standard deviation both directions, 95 between this one and this one, and 99.7%, so almost 100% between these two. So it kind of breaks it down into probabilities, which is what the normal distribution curve gets used for and other things. Here's how you find standard deviation. First of all, if you're going to find out how far stuff is from the mean, you have to start by finding the mean. Then you're going to subtract the mean from everything. And I'm going to go ahead and do those first two steps. I'm going to add up all of these numbers in my calculator, but I'm not going to show you my calculator because it's kind of cracked. 18 plus 19 plus 20 plus 22 plus 25 plus 28 is 132. And then that is 1, 2, 3, 4, 5, 6 numbers. So I'm going to divide it by 6. So down here at the bottom, I'm going to write total 132 because that's what they added to. And for my mean, I'm dividing by 6 because there's 6 numbers. It's 22. Then what I'm going to do is list all my values. 18, 19, 20, 22, 25, 28. And then I'm going to subtract 22 from all of them. So 18 minus 22 is negative 4. 19 minus 22 is negative 3. 20 minus 22 is negative 2. 22 minus 22 is 0. 25 minus 22 is 3. And 28 minus 22 is 6. Then you are going to square those values. Think of these as your instructions. So negative 4 squared is 16, negative 3 squared is 9, negative 2 squared is 4, 0 squared is 0, 3 squared is 9, 6 squared is 36. Notice how there are no negatives right here. Okay? If you find the mean of all of these numbers, that is called the variance. So what I'm going to do is add together 16 plus 9 plus 4 plus 0 plus 9 plus 36. And I get 74. And then I have to divide that by 6 again. 12.33. Repeating. And the last step is we want the standard deviation, not the variance. The only difference is that this one's already squared. So how do we get rid of a squared? We square root. So I'm going to do the square root of 12.33. And I'll kind of show you, I know this looks terrible. If you hit the blue button and then you hit the x squared button, that's the square root. So square root of 12.33 is 3.5. So what that means is 70% of our numbers fall within 3.5 away from 22, which would technically include these three, because here's 22, and these are the only ones that fall within 3 of it. 19 works, sorry. 18 is what I was going to say, is 4 away, so it doesn't fit within 3.5. And 28 is 6 away. It definitely doesn't fit within 3.5. So it's saying that the average distance from the mean, which is 22, is 3.5. Okay, we're going to do the same thing over here, but I'm going to go a little bit quicker through it. It's not as much understanding what you're doing as knowing that this is how you find standard deviation. So first thing I'm going to do is go ahead and list my numbers. 93, 94, 83, 102, 88. And that's actually all the numbers we have. So I actually don't even need this. And that might happen on the homework, it might not. Sometimes it happens. So I'm going to add all these up together, and I'll just go ahead and show you my calculator. Just know that my phone screen is cracked. Okay, so they add up to 460, and then I have to divide by 5 because there's only 5 numbers this time. 92. So then I'm just going to figure out 93 is 1 away, 94 is 2 away, 83 is 9 away. If I subtract it, though, I technically get negative 9. 102 is 10 away, and 88 is negative 4 away. So I'm just taking these numbers minus this. And you don't have to put the negatives if you're like, oh, I know these are 4 away. You don't have to put the negative on the 4. And then you square them. 1 squared is 1, 2 squared is 4, 9 squared is 81, 10 squared is 100, 4 squared is 16. Add them all together. And divide by 5 because there's still 5 numbers. We didn't magically gain any numbers. And then do the square root. So this one, and then that would round to 36. So notice how there's a 5 or 6 after the 5. That makes this round up to 36 instead of 35. And we are rounding to 2 decimal places. And that means these numbers are all about 6 away. So if 92 is my mean, I could do anything up to 98. So let's see, 94, 93. And anything down to 92 minus 6 is 86. So those are my numbers that fit within 6 of my standard deviation. Whose ages are more spread out? These were about 3 apart. These were about 6 apart. That's way further away. We want the smaller standard deviation to be closer together. So that would be the cousins. Yay for cousins. That exclamation point looked weird.